Alrighty, so we've got some parts here. Valve cover gaskets. I bought a set of stock spark plug wires, but since they use the distributor, I may not use them, and I'm going to show you what I'm going to use instead. I'm going to do some unboxing here. Looks like I need a sharper knife, doesn't it? Let's see how to open these. Here we go. So we're going to go with a coil per plug approach. One of these will be mounted, and then with each of these, that will be mounted above each spark plug on the valve cover. Got these spark plug wires, which will go from each coil to each spark plug with these ceramic boots on the bottom of them so they don't burn up from the heat, especially just being still. So this should last nicely. Also, and you'll start to see here that the project has gone from super budget to a little bit more than that. So now we have coil on plug, or coil per plug, and this is a Cherry GS100502 sensor. It's a variable reluctance sensor to be used as a crank pickup. And when you do EFI, you also have to have a cam pickup. The stock distributor does not have that. It has a 6-point reluctor system, so it will enable trigger for each cylinder as the cycle continues. That's not what we need here. We need one pulse per cam revolution, so one every other crankshaft revolution. So in order to facilitate that, the early 2000s Vortec V8s have a distributor that has that sort of setup. I will not be using this distributor. I will be using the parts out of this distributor, specifically the, hang on, let me get a screwdriver and see if we can open this thing up. I found the most high-tech screwdriver I could find. The screws are a lot longer than I expected. Alright, so we won't be needing that distributor cap. We will also not be needing this rotor cap. And inside of here, what we're going to find is a sensor and a window, a sensor window, that when that window comes around, it's going to trigger to tell the computer that cylinder 1 is there. So here you go. So it opens up on one side, the other side is closed, and that's enough to tell the computer that we're on the number 1 side or the number, the opposite. I think it's number, well, I don't know what it is on a V6. It would be number 6 on a Chevrolet V8, I believe. You can correct me if I'm wrong there. Anyway, so this mechanism here will end up in some way mounted to either the distributor that is in the engine, or some part of this distributor will be adapted to that distributor such that this will work within that engine. So that gives us spark and fuel timing. Because it is multi-port injection, we can also do sequential injection, which is nice. Why would I want sequential injection? Why do I want all this trouble for a generator? Am I looking to get huge horsepower out of it? No. The answer is efficiency. If I can make it so I can run the least amount of fuel, that means it will run longer. on a tank of fuel, which is really the goal. I mentioned this a little while back, but this is a control box that allows you to drive the RPM of an engine. And along with that control box is a control actuator. And this actuator is driven by that controller and will, move the throttle butterfly according to the RPM. Now this also has a pickup that's separate from the engine controls pickup. This is another engine control, but a different system. This is another variable reluctance sensor that reads the teeth on the flywheel. So the flywheel teeth will get read by this. They're only, a quarter of an inch apart or something like that. So you have, 150 of them or something per revolution. So you have a pretty high resolution sensing device. And it will adjust this and adjust the throttle body according to load, according to any variance in RPM effectively. So anything that changes it, it will try to bring it back into to hit 1800 RPM exactly. So those will be used. Put these back away. Also, I went ahead and picked up a new oil filter because that is needed. We'll see if this guy fits properly. I hope it does. It looks a little different than the one that's on there, but we will be putting that on in the near future. So that gives us spark, that gives us throttle control, and then also I went ahead and picked up a Fiero intake manifold. So multi-port fuel injection. It's pretty old, it's pretty janky. I don't know how much of this I will use. The good thing is it has an intake base that is drilled for injectors and also has the fuel rail that goes along with it. It has a fuel pressure regulator in here. I don't know, again, if I will use that. I may machine that and close it up and just use an external regulator on the system. That's all TBD at the moment. The throttle butterfly here, would be controlled by the actuator. But again, I don't know if I want to use the top of this manifold. I think I want to use the bottom of this manifold. I may or may not want to use the top. But it may be the easiest choice. So we may end up just using the entire thing. We'll see. We have plenty of space. It's out in the middle of the open, so it should be fine. Now the question is, you're probably asking, why would I not just use this entire thing? It's made for that engine and it should just fit right on. These are known for these gasket surfaces, either warping or leaking. So, do I want a maintenance nightmare on my hands? Not really. But if the gaskets are good and, the bolts don't get over tightened and stuff, it may be okay. I'm sure there are tons of cars driving around with these out there. And if necessary, I can mill the surfaces flat to make sure that they connect properly and don't leak. So this may be the right choice. There are some extra ports and things on this manifold because it's an early, let's see, where is it? There is a, let's see here. There is, in some of these early Chevrolet or GM manifolds have an early start enrichment valve that goes on them. So that will have to be closed up. I don't know if this has EGR. I'll have to see. Anyway, lots of work to do there. First off, get it into the, get it connected to the generator and get it up on a stand and be able to support itself and rotate the generator when the engine rotates. That's kind of step one. Once that's sorted out, then also I went ahead and purchased a large piece of 1/2-inch aluminum. This 1/2-inch aluminum will be the plate, or in part, the plate that goes between the engine and the generator. So more to be seen there. That's basically an 18-inch circle on the generator side, and on the engine side, it's a very specific bolt pattern. I think this will end up being, I don't know yet, actually. We'll see. we'll see what happens here. I may use the bell housing from the engine, or I may not. Lots to be determined there. So that's the bunch of goodies. Lots of things to put together. I have a project I need to do before I can finalize all of this, which is to get my mill working. My mill has been taken apart for a little while, mainly for maintenance. Nothing's really wrong with it. There was something wrong with it. It had a bearing that was out. That is now replaced, and it is working well now. However, I have the scales off of it, and I put a new scale on the y-axis that I have not hooked up yet. And so I'm going to do some touch-up painting on the mill, and then I'm going to put that new scale on and get it adjusted to work with the controls. And then we will start to create the adapter for the engine and the alternator, which will then allow us to put that together and start thinking about doing fuel and spark. So thanks for watching. Hopefully this is enjoyable. Have a good one. Well, I seem to be missing on all accounts. I had this piece of aluminum here, and that piece of aluminum is nice and large around, but it's literally 2 millimeters or more or less too short to build the base of this. I mean, I could really try to stretch it, but it's probably not worth it. As well, it's a little bit too large, so I'd have to cut a lot off the diameter, which means I need to go order something. So that's a bummer. I have pieces, I just don't have the right ones for what I actually need for this job. So we purchase. Talk to you later. Okay, so this is the Chevrolet V8 distributor, and this is the 90-degree V6 distributor. You can notice that the lengths of these are a little bit different, but also the diameters are different by only 0.04 of an inch. But that means that this shaft will not fit inside of this distributor without reaming out the bronze bushings. This is the reluctor setup from the top of this, and this is what triggers the reluctor. This is a GM pickup module, which basically takes the variable reluctance sensor and converts that into a signal. But also it has other wires that go to the ECM through this wiring harness, as well as the capacitor there. The gears are just slightly different. I think the diameter is probably the same, but the inner diameter is a little bit different, as I mentioned before. The bushings are roughly the same. Obviously the housings are quite a bit different. I was checking to see if maybe I could just mount this distributor much lower in the bore and just press a little piece over this to be this size, to see if that would work. I don't know if it will work. I'll have to do those measurements with the intake in place, which I don't have right now. But those are the differences. This is the pickup for the Vortec V8, and that just sits right inside of this here. Again, I want to use the top of this distributor and the top of this shaft so that I can make use of the weatherproof housing on top. So that's the goal. So the alternator is cleaned up, sandblasted, painted. Normally I wouldn't paint an alternator like this. I would just bead blast it and then leave it the natural surface. But this one was very oxidized and it's going to live outside, so I decided I was just going to go ahead and paint it black. Same with the back cover. I still need to replace this bearing. I've got a rebuild kit on the way, so I'll swap that bearing out along with all of the electrical internals. I need to test this still. I ran this through the lathe a little bit with some fine sandpaper. This one you cannot fill with a fingernail. This one I can fill just a little tiny bit. I may do it again to try to get that to be nice and smooth. Maybe not. The kit comes with one of these little seals for the front bearing, as well as a nut and a washer. Got the fan all cleaned up, along with the pulley that goes with it, as well as a couple of other things. I pulled the throttle body off of the multi-port fuel injection system. I pulled the butterfly out of it because I needed to sandblast this case. These are the screws for the butterfly. You have to grind the backs of the screws just a little bit because they kind of mushroom them over. This is the butterfly for it, which I need to clean up still, and then put that back in. Also, you can notice that in here you see kind of a machined finish. Well, that was a pretty corroded finish inside of there. I ran a brake hone through here just a little bit to make it nice and round again. I tried not to take too much material off. There's still some pits in it. Remember, this was not off of the original engine, so this was sitting outside somewhere else for some time. But in any case, I've got the components for it painted up and ready to go together. I'm considering spraying some paint on this throttle body as well as the rest of the intake components. This is off of the multi-port fuel injection system. This has been in the ultrasonic cleaner for quite a long time. It was basically brown all over inside of there. Most of that is now gone. So now it's a matter of getting a new regulator set up for this, or capping this off completely and doing a custom external regulator on this system, which might be a little bit easier to maintain. So that remains to be seen. Cleaned up the water neck for it as well as some of the components that go on the bottom of the throttle body. I'm not sure exactly which way that goes. It goes this way. That goes on the bottom. This is probably going to be needed. It has the idle air control valve that sits inside of it to control the idle. Even if I don't use the idle air control valve, I will need this plate such that the idle speed can be controlled. I probably will wire up the idle air control anyway, and then when you flip a switch, the RPM controls will take over, bring it to 1800, and just keep it there. So you can idle it down, it'll run, and so forth. You still get this masking tape off of here. Looks like there's still some sand in there as well. So some of these components still have the tape on them from when I painted them. So I'll have to go back through that with a razor blade or something to get all of those tiny bits off of it. I also need a gasket set for this thing. And then the next thing on my docket here is to put all this aside and then take the starter apart and do this exact same thing to the starter. And I'm going to do that next. Well, there we have it. This is the starter that's been sitting out in the open, well, not quite the open, underneath a camper shell in the bushes for many, many years. Probably close to 3 decades. I don't know if it works. I haven't tested it, but this bolt here is bent. I think that happened while taking it apart. It's very rusty. It's probably good in terms of the coils and things like that. So just need to take it apart. And I'll do the same thing. I'll sandblast the metal components as well as the front snout, give it a little bit of paint. I will probably replace this solenoid so that I know that's good. This is very similar to the starter from a small block Chevrolet. I believe it's called a 10MT. Anybody else out there can correct me on that. Maybe you know more about the 60-degree V6s than I do. But it's very similar to the small block Chevrolet starters. This might be a little bit smaller. I'm not sure. But I think a lot of the parts are interchangeable. The snout looks very, very similar. I hope it's the same because most of the kits that I'm finding are for the small block Chevrolet type of starter, small block, big block. Ooh. This one has a copper strip here. I'm used to seeing these with a braided copper wire there. Now there's also a tag on it. Maybe this number will give me some clues as to what to get for it. You're probably asking, why don't I just go buy a rebuilt starter? They're so cheap. Why would you take all the time to do it? And my answer to that is that I know how to do it. It's actually really easy to rebuild these starters. And I kind of trust me more than I trust a rebuild company. Everyone, to each their own. But I've gone through automotive repair training. That was sometime in the late 90s, mid to late 90s. Right about the time when carburation was still a thing, but some cars had fuel injection. So to be a mechanic at the time, you learned both. And it was kind of the last time when you could learn, go through the course and learn both carburation and fuel injection, which is an interesting thing. I've never really considered at the time that carburation wouldn't be a thing that was taught with regard to automotive repair for that much longer. So it's an interesting take on it. This is very tight. There's some rust on the front of this bolt, and I'm pulling it through the aluminum here. Hopefully it will come out without breaking or something like that. Yeah, I guess I should have wire brushed the end of that bolt a little bit so it would go through a little bit better. But here we are. Came out, but it was pretty tough. May also be banged up or something. Threads look pretty okay. Well, no, looks like maybe there was a messed up thread there. Hopefully it didn't ruin the aluminum too bad. Well, of course, it's stuck in the ratchet here. Hopefully we can recover it. We will see. Here's our solenoid. These actually come apart as well, which I will show you in just a minute. This takes an itty-bitty little C-ring plier to get those off. Now let's see what's going on back here. That looks pretty good, actually. And so does this, to be honest. That looks the commutator looks amazing. The brushes actually look really good. Almost like somebody had rebuilt it before. So I'm still going to take it apart. I'll still do my cleanup job. I may not need to replace the brushes on this thing. They look almost brand new, which is really surprising given how many years it's been sitting out. Wow, that's pretty incredible. 30-something years. Huh. I guess it was kept away from the environment just enough with this cover and the metal. The Bendix here probably doesn't need to be replaced, is my guess. It's got a little bit of a kind of a clutch inside of here. It's like a one-way roller clutch. And then, you know, it just slides on the shaft like this. And this is what pushes it from the solenoid. The solenoid forks go on here and push it out. So it's in and it pushes out like that. Okay, so we've got it apart. Mostly apart. Let's take a look at this solenoid and see what's going on in here. Got some parts over there making noise on the bench, which just happens to be an IKEA table that my family's had forever. This is going to be interesting. This is a one side of this hooks to the wire inside. It may be worth trying to straighten this out before I take this nut off, otherwise it's going to be really tough to do. If I can screw this on just far enough, I can straighten the screw back out. Oh, there it goes. Okay. I'm going to put this back together for just a minute to hold this while I straighten that out. I don't know if you can see that, but it's pretty bent here. I'm not exactly sure what happened, but it's not good. It's better already. It's also bent this direction, so let me try that one just a little bit. Okay, so this nut does screw down onto it now. It's a little tough, but it does go. Maybe I saved it here, maybe I didn't, we'll see. So the backside of this screw here touches on a disc that moves back and forth inside of the solenoid. So when the solenoid pulls in, it pushes a disc up next to the battery terminal here, this terminal here, and also this. Oh, actually, no, sorry, that is false. This is the start terminal on this one. There are ones with a fourth terminal that when it pulls in, it will touch these plus the other terminal, and that's for startup for vehicles that have the vehicles that have 4 terminals, the 4th terminal is used to go to the distributor for full power when there's a ballast resistor. The older cars that had a distributor with points had a ballast resistor that would reduce the electrical energy that goes to the coil while the vehicle is running. But for starting, they would give it hot off of the 4th terminal here. So I got a little confused before, but that is what I've worked on, old and new. So my brain is thinking old, and this is a much newer vehicle from about 1986, 1987, which is newer than most cars I work on, or older than most cars that I work on. So most cars that I work on are either something a little bit more modern that is a daily driver for me, or something that is much older, Camaros or Chevelles or something like that. All right, so you can see here, this is the start terminal, and then as the solenoid pushes in, it's going to push on these, which then connects the power from the battery terminal to the starter motor. And you can see this disc is pretty burned up. It's probably worth replacing that. Sometimes you can just flip them over. See, this side looks beautiful. And as well, if you look at this terminal here, you can see this side's the one that's burned, but that side is not. So you can flip this around 180 degrees and basically get a new solenoid situation out of the deal. So it may be worth it for me to simply do that and maybe just tape this side up and tape this hole closed. Actually, you can't really get anything in there, but you can on this side. So just tape this side up so I can, sandblast this case, put a little bit of paint on it, and test it and make sure it works. These are basically beautiful. There's nothing wrong with these brushes at all. However, this one feels a little loose here. I'm not sure why. Oh, it's outside of its holder. I see. This needs to slide back in the slot here. There we go. Yeah. There we go. So these slide back and forth in those slots. That's a little different than the older ones. The older ones were on a lever. Again, a little different than I'm used to. So that's the magnet housing. I'll have to test those and make sure that they're good. And the next time you see this, it will probably be cleaned up and painted. I'll see if I can find a C-clip remover to remove that. I don't know if this is small enough. We're going to see in a second here. Yeah, this is smaller than the tool that I have for it, so I'm going to have to use something else, maybe a pick and a small screwdriver or something, to get that off of there. I just don't have a small enough C-clip tool for that. So I'll do that off camera. Next time you see this, it will be nice and cleaned up and hopefully ready to go. Hopefully I can get the alternator parts plus whatever parts I need for this once I test this. If this is good, I don't think I need any parts. It's just a clean up, paint, re-grease the bushings and put it back together job. The back is also a bushing and it looks like it's been well greased and looks really good actually. So my thinking here is I may not have to buy any parts for this starter. I can flip this disc over. I can turn this 180 degrees. I believe this also has the 180 degrees. It does, yes. So I could do that one as well. And that would mean this is basically a new enough starter for my situation. This will get used a couple of times a year maybe. So there's a ton of brush left on these, and they look fantastic. So this part's good. This part is probably good. This is definitely good. I'll have to measure it out and make sure that there's nothing going on in terms of electrically bad. This looks fine. I'll just have to clean it up and again throw a little bit of paint on it and call it a day. Same with this. Put the bolts in the shaker and get them all cleaned up like I'm doing currently with the alternator. I turned it off right now just because I'm recording this, but they are in walnut shells in a shaker, and then they should come out looking pretty new. So these will go in next in the next batch, and I see here this is a 1109535. So I'll go look up that later on and see what kind of information I can pull from that. But it looks like I don't need to buy anything right now. Well, I scratched my head for a little while to figure out how I was going to sandblast this without getting the sand inside. And this is what I came up with. I used one of the bolts from the starter, put it all the way through this piece of cardboard, all the way out this piece of cardboard. This is double layer cardboard, and it's pretty stout. And then I found a 1032 nut here in the shop, and it's holding together, holds both sides nice and close, nice and tight, and we'll see how it goes. I'll show you the aftermath. Okay, so last time we worked on taking this starter apart and cleaning it all up. I went ahead and threw this in the lathe for a second and just threw some 800 grit sandpaper on here to clean these up really nicely. They looked really nice to begin with, so didn't really need it very much. I also cleaned up this shaft a little bit. There was a little bit of surface rust. I tried to not take very much off of it because I want the diameter of this to be correct to still allow this to slide on it properly. So that's basically done. I'm not doing anything to this particular component. It has a one-way clutch inside of it. I didn't want to put that in the ultrasonic cleaner and pull all the oil out of the inside of that. So I left that be. That will go back on. I'll probably try to just squirt a little bit of oil into it to make sure it's got something. This component worked out really well. With the cardboard pieces on both sides, it kept most of the dirt out of the inside of it. And then I blew it out with some air, and it looks, nearly brand new to me. So that's going to work out really well. These brushes, as I mentioned before, are perfect, ready to go. I have not tested this yet, but I took it all apart, painted it. Everything inside of here looked fine. The disc that was in there, I went ahead and cleaned that up on the lathe slightly with some 800 grit sandpaper as well, and it's basically ready to go. Also painted the screws that go into it in the end all the way through. I think I don't have the, oh, here it is. This is the back part for it. The bushing in there seems fine as well. I'll have to put some new grease in there, and then that will go on the back here. The screws, when I took these out, I don't know if you remember, but this one here has some had some gunk in it. Like this thread is messed up and it pulled some aluminum through when I took it out. So I decided I'm not going to use those anymore. I found these stainless steel socket cap screws that I'm going to go ahead and use instead. So those won't rust as well as they have better threads. And I went ahead and ran a tap through here to make sure that the screws are going to go in and they're not going to gouge the aluminum out. It took just a tiny bit of metal on this one where that screw was tight coming out. I think it'll be fine. So now it's about assembling this. It needs a little bit of grease on some of these components, and then this will go back together. So I think in the next clip we'll probably go ahead and put this starter together.